Hi everyone. Today we'll continue to some reviews of grade 9. This session, in this session, we'll explain or re-explain the similarity. What do we mean by similarity? Normally, by definition, when we have two figures, we say that two figures are similar if an enlargement of one is congruent to the other. So normally we have two similar figures when if we can apply an enlargement to one to obtain the other, to obtain an identical figure of the other. So normally this may also be stated as that two figures are similar if one is an enlargement or reduction of the other. So we will study and we will adopt a new notation concept of enlargement factor, which is called in the upcoming material, the scale factor. So normally we have a figure, we have a B, C, D here, and A prime, B prime, C prime, and D prime. Okay, so normally here these two figures, these two rectangles are similar, not congruent, not identical, but similar. Why? Because normally the blue rectangle, the big one, is an enlargement of the purple one using a center of enlargement, which is O here. Okay, and using an enlargement factor or scale factor K. So normally here, how to in this step we want to ask and do wonder how to enlarge a given figure, how to enlarge A, B, C, D to obtain A prime, B prime, C prime, and D prime. Normally, we should have an enlargement center, okay? And any enlargement center, we can put O here or inside between them, anywhere. Okay, so normally we should have an enlargement center, and we should fix a scale factor. So we draw a ray or different rays because we have here the interested points that give us shape that form the shape of our figure are the vertices A, B, C, and D. So normally, if we interest on these vertices, we will obtain the enlargement of this figure to obtain the blue one. So normally we draw a ray starting from O and going through the each vertex we have. So OA, and we enlarge, we can stretch our ray, okay? And normally we measure OA. We measure the distance OA. We want to enlarge the figure. So normally OA prime is bigger. Normally OA prime equal to the K, OA prime equal to the K. That's the scale factor multiplied by OA. So normally OA prime as a distance equal, for example, if the scale factor is a 3 by OA. Similarly, for the other vertices B, C, D, and A, we draw the ray OB and we stretch it, okay, up to obtain, and we measure OB, then we obtain OB prime by using the relation OB prime equal to the scale factor 3, sorry, by OB. Okay, and similarly, we complete for the other to obtain C prime and D prime. Then we connect A prime, B prime, C prime, D prime by lines to obtain the enlargement image of ABC. Normally, when we have two similar figures, we can speak and we can discuss the pairs of corresponding matching sides. We have a matching side. Normally, the image of A is A prime, the image of B is B prime. So normally, AB and I prime, B prime is the first pair of corresponding matching sides. As well for B, C, B prime, C prime, B and C, B prime, C prime are also corresponding sides, and D, C, D prime, C prime with, and finally AD with A prime, G prime. Okay, so it is easy to say that the corresponding sides are when a side is the image of the other. Okay. So it is easy to draw a ray through each point and its image, the point of intersection to find. If we have two, we know that we have two similar figures are ready. Also, we want to find the center of enlargement. We don't have, or we don't know the center of enlargement. How to find the center of enlargement? Easy if we don't have O. So normally we draw rays. It is sufficient to have two rays, for example, a ray with connecting or passing through each vertex of each point and its image. So normally A prime, B prime, normally they will intersect on O. So O is the center of enlargement. It is sufficient to draw two rays only. Okay, so it is easy now to complete to enlarge. We have a figure here. We have a trapezoid. Why it is a trapezoid? A trapezoid, it is a quadrilateral having two one pair of opposite side are parallel and the other are not parallel. For example, here PS and QR are parallel, but PQ and SR is not parallel. Okay, it is a trapezoid, so we want to enlarge this trapezoid using enlargement factor of 2. Of 2. So normally, easy to, for example, to draw a row and passing through O and P, and to measure OP. We measure OP, normally we want to OP prime equal to 2, the scale factor 2 by OP. So normally 2 by OP. So if OP is equal to 3 centimeter, so normally OP prime equal to 6 centimeter. So here it is easy to find out that P here is a midpoint of OP prime. This is another thing to think about. Okay. And the same as for OQ. OQ, we draw the ray and we measure OQ. Then we put and we spot the location of of Q prime when OQ prime equal to 2 times OQ. So normally we can say that OP prime, okay, OP prime, or we can say OP prime equal to 2 OP, and also we can say another way it is to find that P prime C prime, normally the corresponding sides like PQ and P prime Q prime, normally P prime Q prime, it is the double P prime Q prime is the double of PQ, or we can say that the quotient P prime Q prime over PQ equal to 2. Okay, so we have different information, and all these information are important to continue our work. So normally we know that P prime, for example, equal to the scale factor times OP. But after that, when we obtain our enlarged figure, which is in yellow here, so normally each corresponding, we have a relation between each pair of corresponding sides. So normally P prime, Q prime is the double of PQ, Q prime, R prime is equal to 2 by QR, so the double of QR, R prime, S prime equal to the double of RS, and so on. P prime, S prime is the double of PS, or we can, for example, organize our this information using this one. So normally we can by these quotients, by these factors. So normally in the numerator we can, for example, adopt, or we can use only the sides of the enlarged, the new image of the image of the figure, and we in the denominator we use the corresponding of each numerator from the original figure, and finally all these quotients equal to the enlargement factor or the scale factor. What are the properties of two similar figures? So normally if we have two similar figures, then the matching angle are equal and the lengths of the matching sides are in the same ratio. That's what we explained here before, that all the matching sides are in the same ratio equal to the scale factor. Okay. And then the ratio of the lengths of the matching side is equal to the enlargement factor. Okay, we explained before. We should know that if K is smaller than 1, so normally we are going to reduce to have a reduction of the original figure. And if K is greater than 1, so normally we want to enlarge our original figure. But if K is equal to the identity, so normally we are willing to have two congruent figures, or to say simply identical figures. So K is the pivot of our work. So normally, if K, we can distinguish between reduction, enlargement, or identical figures by basing on our scale factor. Okay, so it is easy to say that a new side over the original side, so the length equal to the K, as we worked before, as we explained before. For example, here we have two different figures, and they told us that each pair of figure is similar. So normally we have two pairs of different identical or similar figures. So normally we want to find the numeral. So we want to find the value of the variable given in this figure. So normally, if we first of all, we know that we should be based on the properties of two similar figures. So we know that we know that the lengths of the corresponding sides are in the same ratio. So normally we can say that 24, it is easy to know that 24 over x equal to 40 over 15. So normally equal to the scale factor. We don't have the scale factor, but we have easily 40 over 15. 40 over 15 is the scale factor, in fact. So normally it is 8 over 3. That if the scale factor is 8 over 3, so we can say that 24 over 4 equal to 8 over 3, and we can use the cross multiplication. 8 by x equal to 24. 8 by x equal to 24 by 3. And then when we solve our equation, it is easy to divide both sides, the left-hand side of the equal, the right-hand side of the equal, by 8 to isolate x. So normally to obtain finally x equal to 24 by 3 over 8 equal to 9 centimeters. Centimeter because they use the unit of length here is 9 is the centimeter. And you can use the same way, the same method to find the scale factor and the value of the polynomial in this pair of similar figures also. We should know that all rectangles are equiangular because we know in any rectangle, all the angles are equal to 90 degree, but do not necessarily have their matching side in proportion. So not all rectangles are similar. Okay, we should know that. In the moving on to the exercise 4, we have a triangle STU. So normally STU, which side correspond to MN? We should first of all normally we should know that these two figures are similar and we want to know the corresponding sides. We can base on the property, as we said before, that the corresponding side, the length of the corresponding sides are in the same ratio. So we can easily imagine if we divide 10, for example, by 5, we will obtain a 2. And if we divide 6 by 3, we will obtain it 2. And if we divide 14 by 7, we will obtain it 2. So normally, all these sides are in the same ratio. So normally, we can say that ML is corresponding to TU, and MN and ST are corresponding sides, and NL and SU as well. So it is easy. For example, they give us two figures and they ask us if these two figures are similar or not. So normally, it is easy to know this. We have a parallelogram, two parallelogram here. So normally 4, 4, 10, 10, 4, 4, and 2, 2. So normally, if it is sufficient to say if 4 over 2 equal to 2, but 10 over 4 is different from 2. So normally, because the length of the corresponding angle, corresponding sides are not in the same ratio, so these two parallelograms are not similar. And but the lengths of the corresponding sides for these two trapezoids are in the same ratio, so these two trapezoids are similar and easy. For example, they give us these two similar triangles, and they ask us to name the matching corresponding side in these similar triangles. As a hint, I can say to you that also if we have angle marks, like here we have a small rectangles in bold and small rectangles in bold, small triangles in bold, so angle marks. So we can base our discussion on this angles mark. For example, the opposite side to this triangle and the opposite side of this triangle are similar, are corresponding. So R, Q, X, the Z are the matching sides here. And the opposite for the circle and the opposite for the circle. So normally P, R, and Z, Y, and so on. So easy, easy, easy. And also to find the enlargement factor and of the unknown and and the length of unknown side, these pair of similar figures. So we have a similar figures. We want also to find the same, to use the same weight. For example, the opposite to the circle, the opposite to the circle. So normally we can say that y over 18. Y over 18 is on the same ratio of opposite to the rectangle of 10 over 15. And the same ratio of opposite of rectangle over a triangle, so normally 8 over x. All these ratios or these quotients are in the same ratio. So normally we can lay on this 10 over 15, so it is 2 over 5. 10 over 15, it is a 5 of 5, and 2 over 3, sorry, 2 over 3 is the scale factor for us, and we can use it to find, using cross multiplication to find the y and x. And these are the important idea of the similarity. I wish that I delivered for you important information and the new concept that you can benefit from it. Thank you for listening. Bye bye.